Okay, we're now recording. Recording is on. Let me try to share the screen. All right, so we are up to section 9.3. So we have on schedule all of this. So 1 to 6 odd, 8 and 9, 15 to 18 odd, 35 to 38 odd. Skip anything that's a D. Skip the D problems. Okay, we're doing something called average rate of change. It's not that hard. The quiz today will be an average rate of change. It's basically just slopes. The harder one is the concept called the derivative. Okay, there's a messy formula for the derivative. We have to do derivatives the messy way. And then fortunately, for the sections after that, we start to do things the easier way, but we have to do the hard way first. Okay, so we are here. Flex day is over. It's 9.3. If we go one section a day, we're aiming for Thursday the 25th for exam 3, and that's just before our spring break, so it's a good time to have that. Okay, so that's what's happening. All right, so I'll lecture, and then when I think I'm finished lecturing, then I'll go ahead and give you the quiz, just the usual rules for quizzes, as you should know. Okay, so here we go. Okay, so in my book, so 9.3, rates of change and derivatives. So 2 topics on page 559. The easier one is rates of change. All right, so on page 560, formula for the average rate of change. If you want to put this on your formula sheet, your cheat sheet you made. Okay, so you have a function, f of x, going from a to b, x equals a to x equals b. Average rate of change is f of b minus f of a divided by b minus a. Folks, it's basically y2 minus y1 divided by x2 minus x1. Okay, so they're going to give us a function, and I'll show you how all this works. Okay? And the quiz will be just like that. So they'll give you a function, f of x equals blah, 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 and they'll tell you x goes from one number to another number. You plug in to find the y coordinates. These are basically y coordinates. And then you just do f of b minus f of a divided by b minus a. It's essentially y2 minus y1 divided by x2 minus x1. In fact, I'm going to go ahead and corrupt this book a little bit and tell you this is y2 minus y1 over x2 minus x1. Okay, so it's another way of thinking about the same thing. And you already know that. So you should not have any trouble at all with the quiz because it's y2 minus y1 divided by x2 minus x1 that you've seen before. Okay, so a picture, which you're not going to have to do for any of these, but the picture would be like this. There's some graph to tell you x goes from a to b. So you have the x values. You just need to find the y values. How do you find the y values? You plug into the function. A comma f of a, b comma f of b. The average rate of change is a slope. So f of b minus f of a on top, that's y2 minus y1. And in the bottom, b minus a, that's like x2 minus x1. Okay, so don't be all freaked out by this new formula. It's slope. Okay, it's a slope of the line joining the 2 endpoints that they have here for average rate of change. Okay. All right, I'll show you problems involving that. The harder part is something called the derivative on page 562. Okay, so this is what you want to put in your next cheat sheet. The derivative, it's my 562. You'll have to find it in your version of the text, which is not the same necessarily. So the derivative, we write it like this, f apostrophe x. We say f prime of x. So f prime of x is how you say it. It's a limit. Limit h approaches 0 of f of x plus h minus f of x all over h. Okay, it's a sneaky way of writing slope also. This also is a slope. Okay, h approaches 0, you're taking those 2 points and moving them closer and closer and closer together using the concept of a limit, and we've already seen limits before. Okay, so go ahead and put this on your next cheat sheet. F prime of x, limit h approaches 0, f of x plus h minus f of x all over h. Okay, we've actually seen that quantity before. Okay, all right, so derivative you will see the word or hear the word differentiable. Differentiable means you can take a derivative. Okay, the verb form is differentiate. So if you might hear me say differentiate, yes, there's an English word differentiate. Okay, but in calculus, differentiate means to take a derivative. Okay. Now, what is this derivative good for? Well, they give you a little mini list here on page 566. Okay, we're just scratching the surface of calculus. If you were to take a formal calculus class, you get more of it. But all of these are interpretations of the derivative. Okay, velocity of an object, instantaneous rate of change, marginal, it says marginal revenue, it's marginal anything. It can be marginal cost, marginal profit. Okay, they really should just say marginal. That's a concept in economics. Some of you maybe have had economics. Okay, the concept of the marginal is derivative, and slope of the tangent to the graph of the function. Okay, so if you hear any of these words, you know it's derivative. And it's really no surprise. I mean, it can't be anything else. So in this entire chapter, when you hear this or this or this or this, it means derivative. It's not really any mystery because there isn't any other choice to mix you up. Okay, so in some of the word problems, if it's asked for the velocity, derivative. Instantaneous rate of change, derivative. Marginal revenue, marginal cost, marginal profit, derivative. Slope of the tangent, derivative. Okay. This, granted, is a very messy formula, but we only have to deal with it today. You have to get your feet wet on doing it the hard way, and then starting next time, we get nice derivative shortcuts. Okay, so I'm going to show you how it works now. Okay, so let's show you the problem. So 9.3, the highest is what, 38 in my book. So for those of you that aren't planning to get the book, my page 569. So 1, 2, 3, 4, 5, 6, 7. So you can catch the video, of course. 9. Okay. Then the next page, some more. There's that. And some more. Okay. And if any of you ever get to the point where you look at the video and can't tell what it is, let me know and I'll help you. Okay. For those of you that don't have the book and don't plan on getting it. Some more. Okay, let's see. How high do we have to go up again? 38. So where is 38? Okay, 35 to 38. So that's right there. Yeah, there we are. 35 to 38, and there are the directions. Okay, so that should give you everything that you need. Okay, so average rate of change over a specified interval. Okay, so here we go. Again, I did the calculations before to save time. You want to be able to do it on your own calculator, of course. Okay, and today's quiz will be involve this also. Okay, so average rate of change, again, ignore any dates that I have. This is the last time I taught it, I guess. So average rate of change from x equals a to x equals b, f of b minus f of a divided by b minus a. It's basically y2 minus y1 divided by x2 minus x1. Okay. So problem 2, f of x is 6 minus x squared. Question A says go from -1 to 2. These are both x values. That's like x1 and x2. Part B says to go from 1 to 10. Okay, so part A, you have the x coordinates. You just need the y coordinates. How do I find the y coordinates? I just plug in. So f of -1, put -1 right there, -1 right there. So 6 minus a -1 minus -1 squared. This is double negative. 6 plus 1 minus 1, so that's 6. So this point is -1, 6. Okay, and then they tell me to plug in 2, f of 2. So plug in 2 right there and right there. 6 minus 2 squared. 6 minus 2 minus 4 is 0. So the second point is 2, 0. So -1, 6, 2, 0. So now what is the average rate of change? I just find the slope. of the line joining these 2 points. So y2 minus y1 divided by x2 minus x1. So even though they write it like this, f of b minus f of a divided by b minus a, that looks scary. It's the slope that you've seen way back in algebra 1, algebra 2, and so on, right? y2 minus y1 over x2 minus x1. So I subtract the y's. 0 minus 6 divided by, subtract the x's, 2 minus a negative 1. Negative 6 divided by 3, negative 2. That's all there is to it. Okay, the average rate of change, so digging a little deeper, this function dropped from 6 to 0. So a net change of negative 6 in 3 units, from negative 1 to 2 is 3. So I dropped 6 in 3 units. That's a net of negative 2 per unit, right? Change in y divided by change in x. Okay, part B, they tell me to go from 1 to 10. Same function, plug in 1, plug in 10, and then go from there. Okay, so f of 1. So plug in 1, 6 minus 1 minus 1 squared. 6 minus 1 minus 1 squared, that's 6 minus 1 minus 1 is 4. So 1 comma 4. Okay, and then they tell me to plug in 10. So 6 minus 10 squared. 6 minus 10 minus 10 squared. 10 squared is 100. 6 minus 10 minus 100 comes out to be negative 104. Okay, so the second point is 10 comma negative 104. Just plug it in. Now I find a slope, average rate of change. So negative 104 minus 4 divided by 10 minus 1. Okay, so it's a negative 108 divided by 9, negative 12. So the answer is negative 12. Okay, the average rate of change is negative 12 per unit. So the total drop from a positive 4 to a negative 104, that's a drop of 108 units. Okay, and that's spread out over 9 units from 1 to 10. So that's an average of a drop of 12 per unit. Okay. All right. Okay, number 6. Sort of the same, but it's leading to the idea of a derivative. Number 6, the function they give me is x squared plus 3x plus 7. Find the average rate of change over each of the following pairs of intervals. They go 1.9 to 2, 1.99 to 2, 2 to 2.1, 2 to 2.01. So I just do the same thing, y2 minus y1 divided by x2 minus x1. But notice from 1.99 to 2 is very close. And 2 to 2.01 is also very close. Okay. So we're coming up with an estimate of the instantaneous rate of change, which is the concept of the derivative that we're going to get. Okay, but otherwise, let's just go ahead with it. And the way I decided to do that was to just make a table. Okay, so all the numbers that told me to plug in are 1.9, 1.99, 2, 2.01, and 2.1. Okay, so to save time, take my word for it. You can punch it in yourself, double check that you do it. I plug in 1.9, right? 1.9 squared plus 3 times 1.9 plus 7 comes out to be 16.31. You can take my word for it or try it yourself. 1.99, plug 1.99 there, 1.99 there, 16.9301. 2 gives me 17. I can do that. 2 squared is 4. Let's see, 3 times 2 is 6. That's 4 plus 6 is 10 plus 7 is 17. Plug in 2.01 here and here, 17.0701. And 2.1, plug it in, 17.71. Okay. All right, so they're asking me for the average rate of change on these intervals. Okay, so from 1.9 to 2, remember these are x values. The y values are here and here, right? So I'm taking that one and that one. 1.9 comma 16.31 and 2 comma 17. Throw it in the formula for slope. So m is 17 minus 16.31 divided by 2 minus 1.9 comes out to be 6.9. Okay, 1.99 in 2. That means I take this point and this point. 1.99 comma 16.9301 and 2 comma 17. Do the same thing. Y2 minus Y1 divided by X2 minus X1. So 17 minus 16.9301 divided by 2 minus 1.99. Okay, I did it before, saving time, 6.99. Okay, then it said from 2 to 2.1. Notice they're always picking the 2. So from here to here. So 2 comma 17, 2.1, 17.71. So 17.71 minus 17 divided by 2.1 minus 2, 7.1. And finally, 2 to 2.01, I'm using this point and this point, 2 comma 17, 2.01 comma 17.0701. Y2 minus Y1 divided by X2 minus X1. So 17.0701 minus 17 divided by 2.01 minus 2, 7.01. Okay, that's average rate of change. So your quiz today will just be that. Okay, now they want you to look at the progression: 6.9, 6.99, 7.1, 7.01. It looks like as we move in closer toward 2, the slopes approach 7, or we get close to 7 as a limit. Okay, so it appears that the slopes approach 7, or we would say the instantaneous rate of change is 7, or the language we would say now is derivative is 7. Okay, the average rate of change over smaller and smaller intervals. So I take the interval to be really, really, really small. We approach something called the instantaneous rate of change, or the derivative. Okay, so now the rest of the time I'll talk about the derivative. Okay, so we have a formal definition of a derivative. Okay, so again, how do we say this? You put F and apostrophe and X. We say F prime of X. That's the language that we say. We could also say Y prime. Okay, symbol for derivative. Now, how do I formalize that concept? So I'll show you now on some graph. So here's a graph. So what's the function? We don't know and we don't care. Okay, here's X plus H. So I'm going to write this X comma F of X. The Y value is F of X plus H comma F of X plus H. Okay, so if I want the slope of the line joining these 2 points, it's Y2 minus Y1 divided by X2 minus X1. So it's F of X plus H minus F of X divided by X plus H minus X. I have it here as Y2 minus Y1 divided by X2 minus X1. Now, you can't do anything with this, but you can simplify this. What's X plus H minus X? Well, X cancels out, you just have H. For the derivative F prime of X, I let these 2 points get really, 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 really close. In calculus language, H approaches 0. Okay, so that's where we get the formula for the derivative. Take this slope, F of X plus H minus F of X all over H. And now we take the limit as H approaches 0 of F of X plus H minus F of X all over H. Okay, so here's the definition of the derivative. Okay, so we'll be doing some problems where we're going to plug into this. Okay, now, if you did not understand this derivation here, that's okay. Don't worry about that. Some of you might get it. I'm supposed to show it to you, but you're not responsible for that. I'm responsible for that. You're responsible for doing some problems involving this. And this is, of course, the hard part. But fortunately, after today, once you do the hard part, then we give you the easier part for finding these derivatives. Okay, so symbol for derivative, F prime of X, the apostrophe, or Y prime. Okay, so derivative, what's so good about the derivative? Any of these things on that page, you can put it down on your formula sheet, but in my opinion, you don't really have to. it's not going to be anything else. So you should not wonder, when I see one of these, I wonder what should I do? You take the derivative. This whole chapter is derivative, more derivatives. Velocity, instantaneous rate of change, marginal, slope of the tangent. Once you hear those words, you know you do the derivative. Okay. All right, so here we go. Question number 8. Okay, so 8, they're giving you f of x is 3x squared plus 2x plus 11. They're already telling you the derivative is 6x plus 2. Okay, you will learn how to do that quickly starting next time, but we don't know that yet. Just assume that's true. Okay, A, instantaneous rate of change, derivative. B, slope of the tangent to the graph, derivative. Okay, C, the point on a graph at x equals 6. Well, that one you just plug into the original function. Okay, so A and B should be the same answer. Okay, instantaneous rate of change, slope of the tangent line for question 8. All right. All right, so they already tell me this is the derivative. So A, whatever language they said, instantaneous rate of change, plug in 6. 6 times 6 plus 2, 38. B, slope of the tangent, automatically it's 38. It's the exact same answer. We already said that. C, however, asks for a point on the graph. If I want the point on the graph, I plug 6 back to the original function. Okay, remember in algebra, y equals f of x. You're looking for the y coordinate. So to find a y coordinate, you plug into here, not to here. Okay, so 6 goes here. So 3 times 6 squared plus 2 times 6 plus 11. 3 times 36 plus 12 plus 11. Punch it in your calculator. It's 131. So 6 comma 131. Okay. All right. So I'm going to show you that one. Okay, and then going back to number 4, and your number 3 is similar. This time they just give you a table. They already give you the x and y. See where it says f of x? That's already y. So from 3 to 3.5, I'm using 3 comma 18 and 3.5 comma 15. 2 to 6, 2 comma 25, 6 comma 38. Again, unfortunately, I can't show you both at the same time. So you have to take my word for it, but you're just reading it right off the table. So it's actually easier. There's no computing to do. Just read it right off the table. So part A, 3 to 18, 3.5 to 15. Okay, so the average rate of change, slope, 15 minus 18 divided by 3.5 minus 3. Punch it in your calculator, it's negative 6. Then part B, it said to go from 2 to 6. On the table, it was 2 comma 25 and 6 comma 38. So same thing, y2 minus y1 divided by x2 minus x1. So 38 minus 25 divided by 6 minus 2, 13 over 4. All right. Okay, now for the much harder problems, actually finding derivatives. Okay, so I'll try to show you at least one of each type. All right, so let's see. I was going to show you 16 because you had 15 through 18, right? So I'll show you 16. 16, f of x equals 16x squared minus 4x plus 2 at x equals 1. Find the derivative, instantaneous rate of change, slope of the tangent. All of these are identical. Once you have the answer to A, you got the answer to B and C. Derivative, instantaneous rate of change, derivative, slope of the tangent, derivative. Okay, so the hard part is finding this weird derivative. So 16x squared minus 4x plus 2 at x equals 1. Okay. So here we go. So f prime of x, by formula, it's limit h approaches 0, f of x plus h minus f of x all over h. Okay, now the bottom is easy. The bottom is always h. This is not that hard either. F of x is just the original function in parentheses. So just put in parentheses 16x squared minus 4x plus 2. Okay. Again, I'm using the formula for the derivative. Okay, the definition of the derivative. Put that in your cheat sheet. Okay. This thing. Limit h approaches 0, f of x plus h minus f of x all over h. Okay. All right, the hard part is f of x plus h. What you have to do is pretend you erase that x, erase x, put parentheses x plus h. Same thing here, erase x, put parentheses x plus h. So my f of x plus h is bracket 16 parentheses x plus h squared minus 4 parentheses x plus h plus 2. So everything inside the brackets there is f of x plus h. Minus in parentheses the original f of x all over h. Okay, now for these problems, you're never going to be able to plug in right away. That's too easy, okay, because you'll be dividing by 0. What you'll have to do is cancel that h with an h on top somewhere, and then you'll be able to plug in. Right, remember that section that we were doing on limits? The real easy ones, you just plug in, right? And then later they were harder because if you plug in, you're dividing by 0, so you need to cancel out the 0 somehow. All right, so the top looks like some heavy duty algebra. Let's see, x plus h squared is x squared plus 2xh plus h squared. This is minus 4x minus 4h plus 2. And then over here, minus parentheses. Minus parentheses means change every sign, right? So minus 16x squared minus a minus, so plus 4x minus 2. And now I'm going to distribute a 16. So 16x squared plus 16 times 2 is 32xh plus 16h squared. And then I just copied all the rest of this junk. Minus 4x minus 4h plus 2 minus 16x squared plus 4x minus 2. Okay, so I have this super long numerator, but fortunately a lot of stuff cancels out. 16x squared minus 16x squared cancels out. Minus 4x plus 4x cancels out. Plus 2 minus 2 cancels out. That's nice. Which now means I have that one, and that one. And notice they all have a common factor of h. Factor out the h. By the way, you might say, well, can I factor out, let's say 4? You don't really have to. See, the 4 is not the problem. The h is the problem. So normally we won't factor out a constant like a 4, just only the h. So h parentheses 32x plus 16h minus 4 divided by h. And now the h's cancel out, giving me limit h approaches 0, 32x plus 16h minus 4. Okay, now that I have no h on the bottom, well, there is no bottom, I can just plug in 0. So plug in 0, 16 times 0 is 0. So final answer is 32x minus 4. So the derivative function is 32x minus 4. That's my f prime of x. Okay, so that's a derivative. Now they're going to tell me to plug in whatever. They told me to plug in at x equals 1. So I plug in 1. F prime of 1. 32 times 1 minus 4 is 28. What's the answer to C? Automatically 28. Has to be. Okay. All right, so that's the way that one works. Okay, I'll jump all the way to 36. I'm trying to show you one of each type. So 36, that's from the 35 to 38 bunch. So where is 36? F of x equals x squared plus 3x at -1, -2. A, find the slope of the tangent to the graph, derivative. B, find the slope of the tangent at a given point, derivative. C, write the equation of the tangent line to the graph. Okay, that's different. And I mentioned skip any D's for 35 to 38. Okay. So find the derivative of x squared plus 3x. Okay, so f prime of x, limit h approaches 0, f of x plus h minus f of x over h in general. So limit h approaches 0, great big fraction bar. The bottom is just h. This part I claim is not that bad. You just copy the original function. It's minus f of x, right? What was f of x? X squared plus 3x in parentheses. Now, how do I do this? Erase that x, put parentheses x plus h. Erase that x, put parentheses x plus h. That's what it's going to look like. So it's x plus h squared plus 3 times x plus h. This is f of x plus h minus f of x all over h. Okay, and once again, we have some heavy duty algebra. X plus h squared, x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x all over h. And once again, I get some nice cancellations. X squared cancels out. 3x cancels out. So what do I have left are that one, and that one. They all have an h. So you factor out that h parentheses, and then that h is going to cancel that h. That's the way these derivative problems almost always work. Okay, you get an h on the top to cancel the h on the bottom. So h paren 2x plus h plus 3. Cancel out the h's. Limit h approaches 0, 2x plus h plus 3. Now you plug in 0 for h, so that's gone. So the derivative function is 2x plus 3. All right, and now they give me the point -1, -2. I plug in -1. Okay, so what about -2? You don't have to worry about it because that's y. My expression doesn't have any y, it only has x. Okay, so the answer to B, f prime of x is 2x plus 3, plug in -1. 2 times -1 plus 3, which is 1. That's a slope of the tangent line. So the tangent line is a line that just grazes the graph like so. It's called a tangent line. The equation of the tangent line, put it in point slope form. That was back for algebra. So remember the point slope form, y minus y1 equals m times x minus x1. They already give us the point, -1, -2. We had to figure out the slope. We now figured out the slope is 1. Okay, so plug everything in. Y minus y1, which is -2, equals m is 1, x minus a -1. So y minus a -2 equals 1 times x minus a -1. Okay, double negative, y plus 2 equals x plus 1, and subtract 2, y equals x minus 1. So this is the equation of the tangent line. For this curve, okay, whatever it looks like, it grazes the graph at one point. What's the equation of that tangent line? Y equals x minus 1. Okay. All right, I'm going to go back and do 18 now. I intentionally went out of order because I wanted to make sure I showed you one of each type. Okay, 18 is a little harder because they have P and Q. Okay, that might be price and quantity. So instead of X and Y, it's P and Q. Otherwise, it's the same thing. 2Q squared minus 4Q plus 5, and at Q equals 2. But derivative, so we do the same thing. Instantaneous rate of change, same answer. Slope of the tangent, same answer. Okay. All right. So here's 18. P of Q is 2Q squared minus 4Q plus 5, and at P equals 2. This could be price and quantity, perhaps. Sorry, that's Q equals 2, my bad. Plugging Q equals 2. So P prime of Q, instead of F prime of X, P prime of Q. All right, so limit H approaches 0. Okay, so right here and right here, erase Q, put Q plus H in parentheses. 2 times parentheses Q plus H squared minus 4 parentheses Q plus H plus 5. So this is F of X plus H, or in this case, it's F of Q plus H, minus the original function in parentheses. So I just copy that. This part here is always just a copy job. 2Q squared minus 4Q plus 5, all divided by H. Okay, let me raise it up for you. Okay, and now some messy algebra. Limit H approaches 0. 2 times Q plus H squared, Q squared plus 2QH plus H squared. Distribute to negative 4, negative 4Q minus 4H plus 5. And minus parentheses means change every sign, right? So minus 2Q squared minus a minus, so plus 4Q minus 5. All over H. And then I distribute to 2. Limit H approaches 0. 2Q squared plus 4QH plus 2H squared. Everything else is just a copy. Okay, and notice, I'm going to look for this too. You need to write math correctly. You're supposed to keep writing limit H approaches 0, limit H approaches 0, limit H approaches 0 until you're ready to plug in. Okay, I mentioned that before when we were doing limits. Okay, so if you don't put it, I can mark it as wrong. Okay, right at the step when you're ready to plug in, then don't write limit H approaches 0 anymore. Okay, your final answer should not say limit whatever. Okay, but keep writing it until you're ready to plug in. All right, so 2Q squared cancels out. 4Q cancels out. 5 cancels out. What does not cancel out are that one, and that one. Can you see what they all have in common? There seems to be a recurring theme here. They all have H. Factor out the H. Guess what happens to that H on top? Cancels the H on the bottom. It always works that way for these kind of problems. So H parentheses, 4Q plus 2H minus 4 all over H. Cancel out the H. You notice I keep writing lim all the way through. So limit H approaches 0 of 4Q plus 2H minus 4. Okay, now I'm ready to plug in 0. So put a 0 there. That makes that a 0. By the way, you don't have to draw that arrow with a 0. I mean, I don't mind if you do, but just for teaching purposes, I put that there. But if you want to go straight from there to there, I'll know what you did. Okay, but in case you're wondering, how did you get rid of that? So you say, oh yeah, I'm plugging in H as 0. Put a 0 there. 2 times 0 is 0. So I have 4Q minus 4. So the derivative function is 4Q minus 4. Okay, now they tell me to plug in 2. So plug in 2. 4 times 2 minus 4 is 4. So the answer to B is 4, and that makes the answer to C automatically 4. I should have put it down. So B is 4 and C is automatically 4. No need to compute again. We already have it. Okay. All right, and then the last one is 38, and then I'm done. Okay, and then I'll give you the quiz. So 38, however, don't get your hopes up too high. This is the longest one, it's the worst one. Okay, so 38, 5x cubed plus 2 at the point -1, -3. So A, find the slope of the tangent to the graph, derivative. B, find the slope at the given point, I plug in. And C, write the equation of the tangent line. Okay, so this one's pretty bad. Okay, f of x is 5x cubed plus 2 at -1, -3. So by formula, f prime of x is limit h approaches 0. Okay, so my f of x plus h, erase that, put x plus h cubed minus 2 minus the original f of x, 5x cubed plus 2, all over h. So I have to take a great big time out and figure out x plus h cubed. So within this box here, that's my timeout, figure out x plus h cubed. X plus h times x plus h times x plus h. I do have a shortcut for x plus h squared. Okay, so I'll take the shortcut for x plus h squared and multiply that by x plus h. Okay, what is x plus h squared? X squared plus 2xh plus h squared. Okay, so that's that. And then I multiply by x plus h. Okay, so I take these three terms, multiply by these. So here we go. X squared times x, x cubed. X squared times h, x squared h. They're all pluses. You can tell it's all plus, right? All you see is plus plus. Okay, take the middle one. 2xh times x, 2x squared h. 2xh times h, 2xh squared. Okay, finally, h squared times x, xh squared. H squared times h, h cubed. Combine like terms, x cubed. These two are like. X squared h plus 2x squared h, 3x squared h. These two are like terms. 2xh squared plus xh squared, 3xh squared. There's an x there. Sorry, not sure we can see it. 3xh squared, and then h cubed. Okay, so this mess, x plus h cubed, is all of this. X cubed plus 3x squared h plus 3xh squared plus h cubed. So I'm going to take all of that mess right there and replace it in there. Okay. So here we go. Limit h approaches 0 of 5 times this thing, right? And I'm going to write all of this. So all of that goes right here, right? That's x plus h cubed. And there's the plus 2 minus 5x cubed minus 2. And then I distribute the 5. Limit h approaches 0. Keep writing lim until you're ready to plug in. So distribute to 5, limit h approaches 0. 5x cubed plus 5 times 3 is 15x squared h plus 5 times 3, 15xh squared plus 5h cubed, copy, plus 2 minus 5x cubed minus 2. Okay, so we're getting there. 5x cubed cancels minus 5x cubed, plus 2 minus 2. So I have that one, and that one. What do they all have in common? H. Factor out to h. H parentheses 15x squared plus 15xh plus 5h squared, all divided by h. h cancels out. Limit h approaches 0, 15x squared plus 15xh plus 5h squared. And once again, just for teaching purposes, I draw the arrow with a 0. But if you don't want to put that on a quiz or homework or the test, you don't have to. Okay, meaning put a 0 there, that's gone. Put a 0 there, that's gone. So the derivative function is 15x squared. Okay. Then they tell me to plug in -1 for x. -3 is y, but again, my expression doesn't have any y. So I plug in -1, f prime of -1. 15 times -1 squared. -1 squared is 1. 15 times 1 is 15. And then they want the equation of the tangent line, point, slope. Y minus y1, -3, equals m times x minus x1, x minus a -1. I'll just clean up the double negative. Y plus 3 equals 15 times x plus 1. Okay, and I'll generally let you stop right here. We could keep going into y equals mx plus b, but we don't feel like it. You know, we can all do that. We're focusing on the calculus now. So if we're focusing on the calculus, we're not going to worry too much about the algebra. So I'm going to let you stop once you get to this stage right here. And there we have it. Okay. All right, and I am now done with what I was going to do from 9.3. So I've shown you even problems from this set pretty much, right? 16, 18, 36, 38. So you end up doing the odd problems. Okay, what time is it? About 5:30? So we have plenty of time. Okay, I'm finished, folks. So anybody has a question, you can either unmute yourself or put it in the chat. And if not, we will go straight to the quiz, and that'll do it for tonight. Okay, so anybody with a question? Okay, I don't see anything in the chat and I don't hear anything. So let's go straight to the quiz. All right, so get your cell phones out or be ready to do a screenshot. And here we go. Hopefully it's not too bad. Find the average rate of change of f of x equals 2x squared minus 4x on the interval from 1 to 5. Okay, average rate of change, 2x squared minus 4x from 1 to 5. 1 and 5 are both x values. Plug in 1 to get a y coordinate. Plug in 5 to get a y coordinate. And then do the slope. Very easy, right? Okay, so I'll hold it just for maybe 10 more seconds. Then I'll assume that you all have it. And in fact, some of you might even be close to done, but hang in there until I make my breakout rooms. As usual, put down your first and last name, everybody else's first and last name. I will grade only one person. I'll look at everybody's, but I'll only grade one. So the only way to be sure that you get full credit is for everybody in your group to have it right, and then just submit it, okay? All right, I'll assume you all have it now. Plug in 1, plug in 5, go from there. Okay, so I will stop the share. I'll stop recording.